In my last video we looked at dividing polynomials. In this video we're going to continue that work and look at a couple of harder examples. So let's start off now with question number 5. We're asked to find the quotient and remainder when 2x to the fourth plus 3x squared plus x minus 3 is divided by x plus 3. So we're dividing a quartic by a linear, which will give us a cubic expression. This one doesn't have a term in x cubed. We've got x to the fourth, x squared, x, and then no x, or if you like, the constant. We should have now, if we're going to set this out normally, a term in x cubed. The way we would do this is to use a placeholder. So using the long division method, I'm going to use a placeholder and put in 0x cubed. This is not essential, but it just makes things slightly easier. So if I go ahead, what I'm going to have now is x plus 3, and we're going to have 2x to the fourth plus 0x cubed plus 3x squared plus x minus 3. So as before in my previous video, I simply say to myself now, how many times is x going to 2x to the fourth? Or, more intuitively, what is 2x to the fourth divided by x? The answer is 2x cubed. I write that just here, and that starts to form my quotient. I now multiply down by the leading term, and that is going to give me 2x to the fourth. So 2x cubed times by x is 2x to the fourth. These values will always be the same, as when we subtract them, they will give us 0. Multiplying down, we're going to get 2x cubed multiplied by positive 3, so that's going to give me plus now the 6x cubed. At this stage, I draw a line underneath, as before, and subtract downwards. 0, then we'll have minus 6x cubed. At this stage, I bring the plus 3x squared down, and stop here. I now say to myself, how many times is x going to negative 6x cubed? Or what is negative 6x cubed divided by x? The answer is now minus 6x squared. We multiply down, we're going to get minus 6x cubed, and then we're going to get now minus 18x squared. Writing that there, we now draw a line underneath and subtract down. Yet again we get 0, and 3x squared subtract negative 18x squared will give me plus 21x squared. I now bring down the x plus x. X is into 21x squared is going to be now plus 21x. I now multiply down, I get plus 21x squared. I multiply down, I get plus 63x. Subtracting down 0, and we're going to get now minus 62x. X minus 63x is minus 62x, and then I bring down the remaining minus 3. X is into negative 62x, or what is negative 62x divided by x? The answer is going to be negative 62. Multiplying down, I get negative 62x, and then we're going to have on that now minus 186. Subtracting down, I get 0. If I do now negative 3 subtract negative 186, that's going to give me plus 183. This is what we call our quotient. So our quotient, as we saw in the last video, and this, the 183, is the remainder. So that's what we get. So if we're asked to find both the quotient and remainder, then we will use either this method or setting up the identity and comparing coefficients. If we're simply asked for the remainder, we will use the remainder theorem, which we will introduce in a later video. We looked at checking this. Now if I wanted to, I could go ahead and check if this is correct. What I'm going to do is just jump ahead and look at using the remainder theorem to check that my remainder is correct. Now, if we've got x plus 3, if I now set up a function, f of x, and let f of x be equal to 2x to the fourth plus 3x squared plus x minus 3, and I do f of negative 3, what we will do is find the remainder. I've chosen negative 3 as if x plus 3 was a factor, then we could evaluate the f of negative 3 and it would have given us 0. So with the remainder theorem, if we evaluate f of negative 3, then we will get the remainder. Now, you might say, well, I don't quite understand that. Let's just take now a quadratic, x squared minus x minus, let's do minus 12. If I were to divide this now by, and we'll put it just here, x minus 4, x minus 4 is a factor of this. We could factor it to x minus 4, x plus 3. So we would expect this to be a factor. Therefore, if I did f of 4, where f of x was x squared minus x minus 12, we would expect this to be 0. All I would do is simply put 4 through here and it would give us 0. So if I did that, f of 4 is going to be 16 minus 4 minus 12, which of course is 0. So we could say now that x minus 4 is a factor. With the remainder theorem, it won't give us a factor, it will just tell us what the remainder is if we divide. So here you can see now that we have x minus 4. In general, if we have now a linear factor of ax minus b and we do f of b over a, this will give us a remainder. And as stated, we'll look at that later. So all I'm saying here is if I evaluate negative 3 through here, I should end up getting this 183. So in the calculator, negative 3, and I'm going to go ahead now and simply plug this in. So we're going to have 2 lots of the answer to the power of 4 plus 3 lots of the answer squared plus the answer then minus 3, and that gives me the 183, which is the remainder I expected. So later on, when we've introduced that, you can use that as a check-in mechanism for your remainder, because it seems quite a big number. Okay, so that is using polynomial long division and using a placeholder. We didn't need to use that method. We could have set up an identity. We know that a quartic divided by a linear would give us a cubic, so I could have written that x plus 3 multiplied by some cubic ax cubed plus bx squared plus cx plus d plus a remainder could now be set equal to 2x to the fourth plus 3x squared plus x minus 3. We could have expanded the left-hand side out and equated coefficients to find the values of a, b, c and d, and then r. You could argue that this is a longer way. I do like it, it has its purposes, but you'll probably agree that for this particular one, the placeholder and the long division certainly makes things slightly easier. You can see that we've got 5 unknowns, a, b, c, d and r. So that would be a different approach. Okay, let's look at question number 6. We're asked to simplify 4x cubed minus 7x squared plus 2x plus 1 all over 2x minus 3. Again, exactly the same as we're doing before. What we're going to do is find a quotient and remainder. The difference with this one is that the coefficient on the term in x is 2. That just makes things slightly more fiddly. I study this, it's a cubic over a linear, which will give us a quadratic. The degree of the numerator is 3, the degree of the denominator is 1, so 3 minus 1 is 2. We've got each term in terms of an x cubed, an x squared, an x, and now a constant, so we've got descending powers of x. I could go ahead and use long division, or I could equate coefficients. I'm going to use both methods to show that we can essentially get the same answer. So this time I've got now 2x minus 3 into 4x cubed minus 7x squared plus 2x plus 1. No placeholders required. So this is quite nice because we've got now a factor of 4 in 2. So 2x squared into 4x cubed, or what is 4x cubed divided by 2x? The answer is going to be now 2x squared. So all I've done here is simply gone ahead now and divided 4x cubed by 2x. So I'm starting to form my quotient at the top. Multiplying down, we get, as expected, 4x cubed. Then we're going to have minus the 6x squared. We subtract downwards, and that's going to give us now 4x cubed minus 4x cubed is 0. This is going to give us now minus x squared, and then we bring the plus 2x down. This is when things get slightly tricky. 2x into negative x squared, or what is negative x squared divided by 2x. The answer is going to be negative 1/2 x. If you want to think about that, if that wasn't intuitive, what would you need to multiply 2x by to get negative x squared? Well, the answer is negative 1/2 x. Multiplying down, that's going to give me now negative x squared plus the 3/2 x, so plus 1.5 x. Subtracting down, that will give me 0, and this will give me plus 1/2 x. I need to bring down the plus 1, and now we go back. So 2x into 1/2 x, or what is 1/2 x divided now by 2x. That's probably easier to think of. So if we think now 1/2 x divided by 2x, the x's will cancel, and of course we will have 1/4. So that will be plus 1/4. We multiply down, that's going to give us plus 1/2 x as we expected, and then we're going to have now negative or minus 3/4. All I'm going to do is subtract down 0. 1 subtract negative 3/4 is going to give me plus 7/4. 7/4 is our remainder, so let's write this here. So remainder, and this right here is our quotient. So if we were to simplify this, we could write this now as the following. So let's just get some space. We could write this now as 2x squared minus 1/2 x plus 1/4, and then plus 7/4 over 2x minus 3. So I'm going to write this as plus 7 over 4 lots of 2x minus 3, and that's simplified. So I've written my remainder now over the original value just here, the divisor. So that's a way of simplifying it. You may say it actually looks nicer like so. That's it's up for discussion, isn't it? But that's what we would get if we did that. So with this one, we've just got to be careful. 2 was quite nice to begin with, and it worked out okay. So can do it exactly that way. Alternatively, we could have set up an identity. 2x minus 3 multiplied now by, if we've got a cubic here and we've got a linear here, it's going to be ax squared plus bx plus c plus the remainder, and that will now give us the cubic expression 4x cubed minus 7x squared plus 2x plus 1. So we should get the same answer as we did before, and of course we can check now by evaluating. So if I wanted to go ahead and evaluate, all I would simply do now here, we've got 2x minus 3. So if I wanted to check my final answer, and we set up now f of x is equal to the 4x cubed minus 7x squared plus 2x plus 1, and we did f of 3 over 2, we could go ahead and check that. I can do this at the end, but it will tell me if my answer was correct in terms of the remainder on the last one. So if I plug this in, we're expecting to see 7 over 4. So in the calculator, what I'm going to do is 3 over 2, or 1.5, so 3 over 2. And then if I simply substitute this in, so we're going to get 4 lots of that answer, which we need to cube, minus 7 lots of the answer, which we need to square. Then we're going to get plus 2 lots of the answer, and we're going to get plus 1, and that gives us a 7 over 4 as a remainder. So if we did use this method, let's look at terms in x cubed. So terms in x cubed. On the left hand side, and I'll show these as we go, we've got now this 2x multiplied by ax squared. Nothing else will give us a term in x cubed. So what we can say from here is that 2a will be equal to the term in x cubed on the right hand side, which is going to be 4. From that, we can see quite clearly that a is going to be 2. So let's just put this over here. A is going to be 2. If we now look at terms in x squared, we've got terms in x squared. Now here we need to find 4 unknowns, a, b, c and r. So let's go ahead and do that. So we'll have now the 2x squared, the 2x multiplied by the bx. We will also have the negative 3 multiplied by the a. So on this we can say from here that 2b, so 2, let's write that in blue so we can see that 2b minus 3a will be equal now to negative 7. So if I do that, that's what we're going to have. Now this is going to give me here 2 lots of a, well that's a is 4, so a is 2. So 2b minus 6, simply subbing in a is equal to 2 here, is equal to negative 7. So that means that b from here is going to be now negative 1/2. So if I do that, we can put that over there. So b is going to be equal to negative 1/2. You might have already decided that you don't like this method, but again, it's an option for you. So that's what we have. Certainly if I had, for example, I was dividing, had to show that it's a fact and it was px squared, it could be seen to be slightly easier. So now what we need to do is the following. We're going to look at terms, we've got terms in x. Let's write x rather than x cubed, so terms in x. So from here, what I'm going to have, if we put this on, terms in x, that's going to give me now the 2cx, then we're going to have now the minus 3bx. So if we write this here, so we've got now on here, let's grab that one, we've got 2c minus, what have we got on here, minus, I've got a little arrow on here, which is quite nice, minus the 3b, so minus 3b, and that will be equal now to 2. That's the term in x on the right hand side. So if I do that, what I'm going to have is 2c, and then we're going to have plus. So we're going to have minus minus, so that's going to be plus 3 over 2b, and that's going to, plus 3 over 2, sorry, it's going to be equal to 2. So from this, if we subtract that, 2 minus 3 over 2 is going to give us a half, divided by 2. C is going to be 1 over 4. So let's write that there. That's, I suppose that's quite annoying, those things on here after a while. So C is going to be positive 1/4. Now, if we look at what we've got, the constants, or if you like, let's the term without independent of x. So let's write this here. What we're going to have then is this. We're going to have minus 3c plus r. So let's write this here. So minus 3c plus r is going to be equal now to the constant just here, which is going to give us 1. So that now is the constant or the term independent of x. So if we look, that's going to give us now minus 3 over 4, as c is 1/4, plus r is equal to 1. So r is equal to 1 plus 3/4, which is 7 over 4. So the remainder is going to be now 7 over 4. If we look at those values, all of those look familiar from before. So what we can simply say is, simplifying this expression here, we're going to now substitute back in 2x squared minus 1/2 x plus now the 1/4, so plus 1/4, and now plus the remainder, which is going to be 7 over 4 lots of 2x minus 3. So that is simplifying it using comparing coefficients. You decide which you prefer. Polynomial long division is probably slightly easier, but it's entirely up to you. So another couple of examples of dividing polynomials.